In this video, we will talk about constructive proof, which is type of direct proof. Let us first understand what is proof, which are the different types of proof, and then later we will discuss the case of constructive proof. Basically, a proof of given statement is essentially converting the argument where statement is true. So whatever statement is given, we will give some arguments and we will try to show that, okay, whatever statement is given, it's a true. So that sequence of statement is known as a proof. Proof are of basically two types, direct proof and indirect proof. So constructive proof is a type of direct proof, whereas contrapositive and contradictions are the types of indirect proof. In constructive proof, we start with the hypothesis and we try to prove the conclusion. That is, the form of such proofs or the statements would be if P implies Q. That means if P is true, then Q is also true. Here, P is known as a premise or the hypothesis and Q is known as the conclusion. In contrapositive, we are exactly inverting the things. So we assume that or we start with that conclusion is false. And from that we derive that, okay, if conclusion is false, then for those cases, premise is also false. And that entire statement is true. So that is how we are proving through the contraposition. And in contradiction, we assume that our assumption is wrong. And through series of steps, we prove that, okay, our assumption, what we have assumed itself is wrong. That means our assumption itself was wrong. And this is how we are deriving the proof. So all this we are going to discuss in detail with examples in upcoming videos. In this particular video, we will talk about constructive proof. A constructive proof is a proof that directly provides a specific example. So through examples, we are proving that, okay, given statement is true. Consider the example that if A and B are odd, then A into B is also odd. So through some series of steps, we will try to prove it. As A and B are odd, that is the given condition, we will consider it as a hypothesis. And what we have to derive is A into B is also odd, that we need to prove. So that will form the conclusion of the statement. So P is A and B are odd and Q would be A into B is odd. A and B are odd. So if we multiply any number by 2, it will become even. And if we add +1 into that, it will become odd. So we'll assume that A is equal to 2x plus 1. So definitely that will ensure that A is odd. And B is also odd. So we'll consider that B is equal to some 2y plus 1. So these two are definitely odd numbers. To prove the conclusion, we have to multiply both the numbers. So A into B is equal to 2x plus 1 into 2y plus 1. Let us simplify them. So that would be 4xy plus 2x plus 2y plus 4. From first three terms, we can take 2 as a common. So that would be 2 into 2xy plus x plus y. And 2 multiplied by something. Assume that 2xy plus x plus y is some number m, which is multiplied by 2. Because 2 is outside that. So 2 into m plus 1. So first term is 2m. So whatever number we have m, may be odd or even. When we multiply it by 2, it will definitely become even. And plus 1 into that, that would be surely odd number. So through this series of sequence, we have proved that if A and B are odd, then A into B is also odd. Consider the another example, that if A and B are even, then A into B is also even. So again, it is a if P then Q kind of statement. So our P would be A and B are even. That is our premise or hypothesis. From that, we have to derive A into B is also even. So that is our conclusion. So that is the Q. So let A is equal to 2x and B is equal to 2y. So x and y could be any value, odd or even, but when we multiply it with 2, it will be definitely become even. So it is already given in premise that A and B are even. So we'll start with A is equal to 2x and B is equal to 2y. Let us multiply it to prove the conclusion. A into B is equal to 2x into 2y. That will be 4xy. We can rewrite it as a 2 into 2xy. 2xy, I'm replacing by m, so we have a 2m. Now whatever may be the value of m, odd, even, we are not worried because it is multiplied by 2, so definitely that number would be even. And hence it is proved that if p is true, then q is also true. So this is how we are deriving the proof through constructive method. For x belongs to z, if 7x plus 9 is even, then x is odd. So as you can see, it is a if p then q kind of statement. So we have p as a 7x plus 9 and q as a x is odd. So let us start with our p. 7x plus 9 is even. As it is even, we can write down it. We can write it as a 7x plus 9 is equal to 2a. Okay, so 2a is always going to be even number. Fine. So let us subtract 6x plus 9 from both the sides. So we have only x on left hand side. So that will ensure that 7x plus 9 minus 6x minus 9 is equal to 2a minus 6x minus 9. Why we chose this number 6x plus 9? Because we want x on left hand side, because we have to prove that x is odd. So if we subtract 6x minus 9 from left hand side of the equation, then that we will have x on left hand side. So ultimately this equation will reduce to x is equal to 2a minus 6 minus 9. Minus 9 I am rewriting as a minus 10 plus 1. Now I can have 2 common in first 3 terms. So I can write it down as a x is equal to 2a minus 3x minus 5 plus 1. A minus 3x minus 5 term could take any value, maybe odd or maybe even. We don't worry. Fine. So let's call it as a m. So we have x is equal to 2m plus 1. 2m is definitely going to be even because any number we multiply with 2, that is going to be even. So 2m plus 1 will be odd. Right? 2m plus 1 will be odd, and that proves that okay, x is odd. So see that how step by step we have proved q from the p. So all if p implies q kind of statement we can easily prove with the constructive proof. So this is how constructive proof is working. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.